All right, so I wanted to speak this morning about building AI together because this is a generational change in the tech stack. There has, in my career, there have been only a few moments where we've seen almost the entire tech stack reconsidered, reevaluated because of new breakthroughs, new innovations. One of those, of course, was the emergence of the internet as a phenomenon. One of those was the emergence of mobile as a phenomenon. One of those was the emergence of cloud and containers. And now we see this extraordinary shift in the way people think about what's possible in the field of technology. And when that happens, it's just an extraordinary privilege to be in the middle of it. And it's something that is far, far bigger than any one organization or team. In the last decade, Ubuntu has been really privileged, or it has been a privilege to be in the middle of some of these big revolutions. As the cloud took off, for example, and developers were essentially transforming the way people thought about infrastructure and operations, Ubuntu very much was at the center of that. The innovation was happening all around us in many different organizations. But because of the way we really focus on the developer, we had the great experience of being in the middle of a transformation of the way enterprise infrastructure is built and run and operated and consumed. And today I feel the same thing. I feel that there is this incredible shift happening in the industry that is being powered by brilliant people in many, many different organizations and universities. And by enabling them to go faster with more confidence with open source, we have the privilege of being, in the middle of this extraordinary change that's happening across the planet. So our role as an operating system or as a platform really is to bring together innovators at every level in the stack. And I hope in the event this week, you're getting a feel for how we're working with each of those different players and each of those different categories of innovator effectively to enable the whole ecosystem to move forward faster and with more confidence. So let me talk through that picture with you today, right? So I want to start with at the bottom of the stack effectively with what we're seeing in silicon. And I'm delighted that we have silicon partners here as part of this event because their innovation is absolutely critical to our experience of AI, both at the level of the institutional experience and data science experience, but also in the end, the consumer experience as well. I believe we are at the beginning of a transformation in silicon. And in fact, the steady state is not yet clear at all as to how that silicon is best going to support this new approach to data and user experience. And that's why we're seeing just an extraordinary range of innovation from many different companies who are thinking about all aspects of AI from the silicon upwards. Clearly, the raw number crunching, the parallel number crunching capability that we all think of as general purpose GPU capability is critical and has been absolutely central to the AI story in the past decade. But we're also seeing new innovations on the consumer side and on the device side as people start to think through the whole life cycle of AI. For us, it's really important to enable the innovation that's happening in silicon to reach developers and ultimately people who are building devices, applications, solutions as smoothly and as simply as possible. Each silicon company has their own idea about what it's truly going to take to deliver AI faster, cheaper, more pervasively in all sorts of different circumstances. And they have teams not just of silicon engineers, but also software engineers working on fundamental research as well as the integration of innovative capabilities, algorithms, and silicon features effectively with tool chains that are open source and are widely available all over the world. So we have essentially a massive parallel innovation and integration challenge, right? In all of these silicon companies, we see deep research going at speed. And to get that software, to get the software that comes out of those silicon companies, to get that into a form which is easily consumable by any developer anywhere in the world is an enormous amount of work. As a platform company, I see that as our most important responsibility, right? To essentially reduce the amount of time between when silicon companies have a new capability in metal and in software, to when the average developer effectively can consume that transparently and easily, and then ultimately to when people who are building products can assume that that is available to them in a form which is not science fiction or science experiment, but which is really production capability. The silicon innovation appears to be moving, at speed on multiple different fronts. We see groups working on the data center and really transforming the way the data center is architected in order to support large-scale training and inference. We see innovation in the client, so in the workstation for developers, which is both for data scientists but also for consumers, trying to figure out how to make put AI at your fingertips in a workstation context. And then we see other classes of silicon being developed for AI at the edge, where effectively the vast majority of data will be processed in real time, so that smart things effectively can make AI-driven decisions without having to essentially move huge amounts of data to central locations, right? So in terms of the physics of latency and transport, AI at the edge is clearly a critical piece of the global puzzle. The next area that I want to sort of concentrate on and celebrate is the developer and data scientist experience. And the workstation really is the heart of innovation for people either in corporate environments or in university environments who are working on the algorithms or essentially the products that are going to put AI in all of our hands tomorrow. And here we work with the PC manufacturers, the workstation manufacturers, to make sure that the latest algorithms and SDKs are available to developers even before those are deeply integrated into widely available operating systems. The pace of change is just so fast that every 3 months, the change that we see in the software stack for an SDK in 3 months is enormously valuable to people. We can't wait effectively for the full integration process to bring those capabilities into the universal platform stack effectively. So we have to deliver those capabilities to developers directly. Our goal ultimately is to make it possible for a developer anywhere in the world to have access to the very latest SDKs, either in a workstation context or in a cloud context, so that they can either do data science analytics and design algorithms and do experiments, or essentially build production capabilities for consumer or enterprise use. The developer experience is a unique problem, because you need to bring together things that are really cloud-like in their experience, but give those capabilities to people in an offline context so that they can essentially work wherever they are with resources that they have available to them in a completely disconnected fashion in some cases. So this is a very interesting piece of work, because it integrates work that is cloud-like and work that is device-like and work that is developer-oriented into a sort of unified experience for people at the workstation. The next piece that I wanted to talk about was the role of the public clouds. And I think we've all been inspired by the pace of innovation and change that we see in cloud computing, driven by the world's largest organizations investing enormous amounts in creating effectively limitless capacity that is available to any developer or institution on tap. It's absolutely clear to me that public cloud computing is going to be central to this wave of innovation. Whether it's access to the latest GPUs, or whether it's essentially integration of the different elements of an AI stack with your production elements, which are already on the cloud. It's just critical that we essentially enable people to work between their workstation and the cloud in a completely seamless and transparent fashion. For me, it's again a privilege to be in the middle of this revolution, because I can see how the different clouds have really staked out unique areas that they're going to innovate and differentiate on. And it's just really important to be able to. It's really important for us to celebrate and reflect to our users the distinctive work that Microsoft is doing, that Google is doing, that Amazon is doing, that Oracle is doing, that IBM is doing, because each of them effectively is identifying as their own strategy and their own capabilities that they're investing in to be able to serve their customers. I want to make sure that a user of Ubuntu can sit down in front of cloud capacity of any cloud and immediately have access to the distinctive capabilities of that cloud. Part of the challenge for people who are operationalizing all of this is the complexity of integration that is required. We live in a world of software abundance. Google, Amazon, and many other companies are contributing to enormous projects and enormous ranges of projects that enable people to process data, analyze that data, and transform that data into usable models and insights. But all of those pieces need to be integrated. It's as if we've shifted from a world where the problem is no longer affording the software. The problem is operating the software, integrating the software, and supporting the software. So this is a key area for us, right? We again, being at the center of so many different open source projects, we're looking to try to understand how to make that integration and operations process reliable, seamless, and easy on any cloud or in people's data center, right? And I think you'll see some examples of how we're doing that with Kubeflow and MLflow and various data science capabilities, data stores, and so on. Our vision here is that you should be able to experiment with and operationalize and put into production any magical piece of complex infrastructure from the open source community at scale, cheaply, effectively, on the cloud of your choice, taking advantage of the silicon of your choice in a really native and straightforward way. So now I want to move to a completely new phenomenon, which is what I would call famous models, right? We've all heard of ChatGPT. We've all heard of Mistral. We've all heard of Claude and Gemini. I think we're entering a world where there are these new capabilities that have brands, that have names, that have meaning, that have value, right? And they are a new class of software, right? They are shared in the same way that Kubeflow is shared, or Kubernetes is shared, or the Linux kernel is shared, because we are seeing open source models that are available to everybody, right? But they present us with new challenges. How do you get access to them? How do you update them? What does it mean to do security maintenance and compliance on these models? And they also represent a really interesting integration problem, because the same idea, a famous model, Claude, Mistral, ChatGPT, Anthropic, any of those famous models, needs to be tuned and optimized, effectively transcoded for different silicon. So there is this problem effectively of how to get the developer and the enterprise the model that they want on the cloud and silicon that they want in a way that's efficient for the purpose that they want to use that model for. So once again, there's this opportunity for us to help the developers of the famous models, the publishers of the famous models, the producers of the silicon, the operators of the clouds, to essentially help integrate all of those capabilities into an experience for developers and production users, which is seamless and straightforward, right? So this is absolutely fascinating. This is a new class of software that, again, requires complex integration in order to turn it into a just works kind of experience for developers and enterprises. All of this ultimately will be completely pervasive in our lives, right? The story today feels very much like a data story, like an abstract story, like a data center cloud story. But in reality, I think AI is going to be in your earpiece. It's going to be in your everyday accessories, in your house, in many different devices in your house. And supporting the developer and entrepreneurial ecosystem that essentially makes the things that we touch and use and which provide our physical, transform our physical environments is really fascinating. IoT is already perhaps the most personally interesting part of the open source landscape, right? Clouds are extraordinary and impressive, but IoT is absolutely real, right, for millions and millions of people in a way that's difficult to difficult to compete with, when you compare it to the very abstract things that we deal with in cloud, right? So bringing AI not just to the edge, but to every aspect of the intelligent edge is a really interesting challenge. My goal is that every house, every factory, every office environment, every farm can be powered by smart things, where we also can reason about security, integrity, compliance, and capability in a very rigorous way, right? So that brings me to the last piece that I wanted to talk about, which for me is one of the critical legs of the whole story, which is to do all of this in a way which preserves confidentiality, that is really, really important, and compliance, which is equally important. There is a talk, I believe, later today on confidential computing, which for me is one of the most exciting things happening in the cloud, right? The ability to work on those shared resources in a way which is truly confidential, and which essentially resolves many of the anxieties and concerns that organizations and individuals have about shared infrastructure. So giving us the benefits of the energy efficiency of shared infrastructure and the operational, the extraordinary operational capabilities of the public cloud, while at the same time enabling people to work with data that is sensitive, either commercially or from a national security point of view, or from a personal privacy perspective, and doing all of that in a way which in the long run will meet regulatory requirements, is a significant set of challenges. All of these pieces have to come together. All of these companies ultimately have to integrate their work and their understanding and their offerings. It is our great challenge and our great privilege to be in a position to work with the world's best silicon companies, clouds, workstation manufacturers, software developers, SDK manufacturers, universities and scientists, and makers of machines and other wonderful things. It's what makes the work that we do truly fascinating and rewarding. So that was everything that I had wanted to share. I'd be delighted to take questions either from folks in the room in London, virtually if we're able to do that, and I'll ask Gloria to steer us through that.
Thank you, Mark. We received 3 questions for you. We're going to try to if you can hear us, do the questions remotely. I'll just pause between questions to make sure you can get our feed correctly. The first one is, container security is a big issue, especially for AI projects. How does Canonical help companies there?
Well, the containers clearly have revolutionized the way people think about application agility, in the cloud, thinking about putting the right workload at the right scale in the right place and with access to the right data and so on. There are a couple of different things that I think we are in a position to significantly improve in the overall experience that enterprises have with containers. The first is container maintenance effectively. Lots of organizations are pulling open source from a very wide range of projects, in addition to the open source they get from the platform like Ubuntu. And in launching our Everything LTS offering, we're essentially saying to enterprises, we will maintain your dependency chain. We will maintain we will essentially make a CVE and compliance commitment to the upstream projects that you are using in your containers, so that you can set up your container build automation and essentially just rebuild containers on a regular basis using those maintained upstream components from Canonical, and know that you can then keep those in production for 10 to 12 years without needing to essentially go back and introduce new versions and breaking changes in your production environment or your legacy application estate. That's the first thing, which is essentially upstream maintenance through Everything LTS and Ubuntu Pro. The second thing is the fundamental security of containers. With our work on deep security primitives in the Linux kernel, AppArmor, and related Mac-based security capabilities, we can wrap containers in tighter sandboxing envelopes. We can make sure that they only have the permissions and the content in them that are needed for their operation. That makes it a lot harder to attack a container, and it makes it a lot harder to attack the system that's running the container, if effectively those two things are working together to make sure that the application in the container is deeply and rigorously confined. So we're in a unique position to do that because we can push forward on kernel confinement capabilities and primitives, as well as making containers for people that for all the standard things that you would want to use from the open source catalog effectively, which have extra metadata and extra rules wrapped around them to restrict their capabilities even more. I would add to that new work that's coming through in essentially putting containers into confidential virtual machines so that you have an extra layer of encryption and defense, both for the application itself running in the container, but also for the system from any vulnerability or malicious code that's running in the container. And again, because we're working with the silicon companies and the clouds and are part of their sort of advanced go-to-market and release schedule, we're able to essentially pull all of that together for the enterprise user, and that makes essentially much easier for everybody to get the benefits of the silicon innovation that's happening and the cloud innovation that's happening, and to get that in real time effectively and move it into production much, much faster. And the last thing I'd say is that the containers that we publish as part of the standard offerings, they have an additional level of intelligence built into them that makes it easier to audit them and ensure that they're compliant, so that it's easier to know exactly what you're running and where the issues might be. It's easier for the CISO effectively across a large organization where people are doing lots of different things with containers to be confident that you at least know where your primary problems are likely to be and where you can focus and concentrate your resources on the issues that are most likely to present real risk.
Thank you, Mark. I think we have time for one more question only. So as projects mature, you need to start running models at the edge. What would your advice be for organizations looking to do that at scale?
In order to put AI at the edge, the first challenge is to empower your developers. Right? Some of that AI is going to be famous models. things that you can quickly get consensus on the room on what you want to put at the edge, what capabilities you want to put at the edge. But a lot of that is going to need to be unique AI capabilities that respond to data in your business and your value proposition. So the critical ingredient, all of that, is that workstation wizardry, right? It's enabling your developers to have all of the open source at their fingertips. That gives them essentially, puts them on a level playing field with your competitors and the people who are the best in the industry. Ubuntu is absolutely the platform for that. Open source is absolutely the platform for that. So enabling them to work with that is job number one. The second piece is going to be essentially enabling them to work in a way that that essentially pulls together that fast-moving capability in software with fast-moving capability in silicon. AI at the edge is absolutely going to depend on silicon, right? It's going to require us to put the right silicon at the edge that enables applications to perform in real time on mission critical data. We're not going to be able to do that with general purpose compute and with the software stack that we have today. You're going to need to essentially bring together the standard frameworks that your developers will be talking about with the optimized versions of those frameworks that come from silicon companies with your choice of silicon based on the unique problem that you're trying to solve. If it's a vision-based problem or another kind of sensor problem, if you're using essentially centralized data, or if you're using third-party data, or if you're using data that's being generated uniquely in your business, your developers are going to have to sort of integrate all of that to build the solution. And then the last piece of all of this, I would say, is figuring out how to operationalize all of that. Again, a lot of our work is in essentially figuring out how a innovation that happens from a developer on a workstation, plus training and capabilities processing that happen in large-scale environments like public and private clouds, how those can both essentially be delivered rapidly and safely and securely to the edge. We're going to have to update edge devices multiple times a day in some cases to address the need for new business capabilities or essentially new learnings in the model effectively, or new security to respond to security threats or regulatory or other compliance requirements. So that ability to essentially make your edge agile is going to be critical to anybody who's operating in the physical world.